All right, let's jump right into this explainer. Today, we're tracing an absolutely fascinating journey. Have you ever stopped to think about how a messy, abstract human thought actually translates directly into a physical, real-world action? Well, that's exactly what we're going to uncover. We're going to track a single thread of logic from the microscopic hardware level all the way up through digital network protocols and finally arrive at a literal physical robot sitting right on your desk.
To map out this descent to the metal, here is our game plan. We'll start with the computational illusion, then cross the semiotic bridge, meet the ShareBot, dive into leaf node logistics, and finally explore the GPIO nervous system.
Okay, part 1. The computational illusion. Does AI actually understand us?
You know, we intuitively feel like computers just get us, right? You ask an AI a complex question, it gives a great answer, and it genuinely feels like it understands what you mean. But beneath the surface, there is a massive, gaping chasm between our organic minds and the hardware. Our human operating system, let's call it OS Alpha, is a continuous, fuzzy flow of associative, creative thought. We deal naturally in context and feeling. But the machine, the arithmetic logic unit inside the microchip, it is completely blind to meaning. It operates on a rigid, deterministic metronome of clocked voltage levels. There are absolutely no semantic symbols down there. It's just continuous electrical currents roughly approximating math.
Which brings us to a, frankly, hilarious but profound realization. When you think about it, we are quite literally tricking rocks into thinking using lightning and text. I mean, we've taken silicon substrates, pumped electricity through them, and used language to force them to execute our wildest imaginations. But the big question is, how exactly do we safely and predictably compile our boundless human thoughts into the physical behavior of a processor?
Well, that brings us to section 2, crossing the semiotic bridge. Since human thought is so probabilistic and silicon is purely rigidly mechanical, we desperately need a flawless translator to bridge that massive gap. And that's where strictly formatted text comes in, stuff like JSON or Python code. It acts as our semiotic bridge. This text is the literal universal interface that safely maps our boundless imagination directly into pure physical physics. Text isn't just for humans texting each other anymore, it's the exact deterministic operational literature of machines. By writing explicit text, you actively force the machine's hardware to execute your intent, with absolutely zero foggy guesswork.
All right, section 3. Meet the ShareBot, the physical switchboard. Let's ground all this abstract philosophy into concrete reality. Meet the Flow X402 ShareBot. It beautifully embodies this exact translation. Now, this isn't just a cool 3D printed collectible for your desk, it's a fully functioning robotic vending machine. If a viewer sends a digital tip online, this physical switchboard instantly reacts. It might dispense a piece of candy, for instance. It's absolute proof that digital callbacks and on-chain state changes can instantly manipulate the physical world and do it without any massive intermediaries bogging things down.
Moving on to section 4, leaf node logistics and achieving high-fidelity execution.
So to understand how the ShareBot actually executes these physical actions so flawlessly, you have to look at the architecture of the network's extreme edges. It's a brilliant root-to-leaf descent. Think of it like this. Your human intent is securely anchored at the root on a digital ledger using a LIFO, that's last in first out, JSON state. That structure guarantees the most recent command is always treated as the absolute truth. From there, that truth is verified across the semiotic bridge trunk by deterministic AI scripters. And finally, it trickles all the way down to physical leaf execution, happening right there on your desk. It's a flawless, step-by-step translation from abstract human desire directly to concrete physical reality.
And that brings us to the climax of this explainer. Section 5, the GPIO nervous system. This is where code truly becomes reality.
We have finally arrived at the absolute bottom of the funnel, the very edge of the digital universe, where pure math actually becomes physical movement. The ShareBot, you see, isn't just an empty plastic shell. It relies on a completely unassuming Raspberry Pi acting as a localized micro-host. It just sits there, patiently reading the verified JSON state tree from the network to identify absolute digital truth, like confirming that a payment webhook actually fired. But once it verifies that truth, how does it physically react?
Enter the ultimate heroes, the GPIO pins, or general purpose input/output.
These tiny metal prongs on the Raspberry Pi act as the literal nervous system of the hardware. They are the exact physical threshold where deterministic digital logic seamlessly translates a verified state change into real-world action. We're talking spinning a motor or lighting up an LED. When a validated line of text command hits the system, these pins physically translate that code into reality by sending out raw electrical signals right into the physical world. It's absolutely wild.
By acting as this nervous system, these pins become the ultimate leaf nodes of our semiotic bridge. They allow you, the human pilot, to apply your creative intent, while the deterministic hardware effortlessly handles the physical sweat. Historically, trying to map digital network data to physical hardware was a total mess of chaotic, event-driven programming. One delayed signal and the whole sequence was ruined. But by tying structured on-chain data directly to these physical pins, we achieve a pure, direct translation of digital truth into physical action, bypassing decades-old technical walls with surgical simplicity, zero guessing, zero complex intermediaries in the middle.
As we wrap up this explainer, it's clear we're entering a totally new paradigm. A world where bit-perfect, absolute digital truth orchestrates physical reality right at the edge of the network. And that leaves us with one final, undeniable question about the future of human authorship. The semiotic bridge is officially built, and the translation from your mind to the metal is seamless. So, what are you going to program physical reality to do? Thanks so much for joining me today. Keep exploring, and I'll catch you next time.